In our last session, we have discussed about the concept of this temperature layers, right? So I will quickly also show you that how does this temperature layer looks, okay, or how these things can be done through the HANA Studio. Although the things which I am showing you now is not mandatory for a functional consultant, but it's a good to know so that you would be actually be understanding that how actually the things would be happening in HANA Studio. And you will also get a little bit overview on the HANA Studio. So to go to the HANA Studio, what we will be doing that we need to log into remote desktop. So let me first quickly log into remote desktop. So you can connect with the remote desktop. You can go to the run command, and from there you can give a command to connect with the remote desktop. This server ID would be provided to you. Okay, and with this server ID, when you will connect it, it will ask you a user ID and password. Once you will put a user ID and password, you will be able to go into the remote desktop. Remote desktop is another desktop which you are working on, and here, whatever the software you need to use for this training is all of the software has been installed here. Okay, so all of the SAP Logon Pad, Fiori, or HANA Studio, whatever you are supposed to use, everything is here. So now, what is first thing I'm going to show you? I'm going to show you that how the data moves between the temperature layers and how we can see through the HANA Studio. So I'm clicking on HANA Studio. It will ask you this message. You just need to click on launch. Okay. On the left hand side, you will see the same way we see in SAP GUI when we log in. We see the server. Here also you will see database. So these are the databases. If you don't have a database here, we will be providing you details. It's very simple. You can click here. You can go to add system and you can add your database by clicking on the add system. Okay. In some cases, what you will find, system will take you, if you are logging in first time, system will take you to this welcome page where it talks about a little bit that what is covered in the HANA Studio, how to use it. So that welcome page can open. You can close the welcome page from here. And this information, if you want to see it, you can easily go to help and go to the welcome page. Now I would be logging in into a HANA database system. So I'm logging into the S4H 1909. So I'm not logging into the 1909 application. Actually, I'm logging in here to S4H 1909 database. It will ask me my password. So for user ID and password, we use for user ID and password, basically we use same user ID and password for database, but we would be having a different user ID and passwords for when we'll be using our 1909 system. So here we need to put a user ID and password. What would be the user ID for our system? For our system, user ID is HANA. User ID is HANA and password would be capital HANA @999. So this is common for everyone. Whenever we'll be connecting to any database, the user ID and password is common. Although to connect it and to check this stuff is not mandatory, but good to have. If you want, you can do. Otherwise, you can skip this exercise, which I am explaining right now. Okay, so let me log in. You guys are able to see my screen, right?
Yeah.
Okay, good. Okay, so when it shows you at the left hand side, you can see here a green signal here. It means this has been we have logged in. The green signal means we have already logged in. So here we are having a multiple things. We are having a catalog, content. Within the catalog, when you will go, you will be having a schemas. Okay, so basically in HANA database, your data stored in schema. I will just give you an overview that what is this concept of schema. So let's say this is your HANA database. Okay, within that there would be a container you can see, which can be schema 1 and which can be schema 2. So basically your S4 1909 data would be sitting in one of these schema. And you can also use another schema to get stored data from another application. It can be SAP application or it can also be non-SAP application. Okay, so it's not mandatory that all the landscape would be like this, but this kind of landscape can also exist where a single HANA database can be used to have a multiple data from the multiple applications. And in HANA Studio, we are having a capability to create views where your HANA consultants would be able to merge these two datas, okay, and create a views and which can be linked with your BI system to generate reporting. Okay, so that functionality is there that can happen with this concept of schemas. Any question on this part till yet before I move ahead?
So the login screen is going to look like this.
For HANA Studio?
Yeah.
Yes, HANA Studio login screen is this.
Mhm.
Now I'm going to know that there are the multiple schema, technical schemas are there. What is our schema, where our data is stored? So to check that, I will log in here through GUI to our S4 HANA 1909. Okay, so here I'm logging through the GUI. Here you need to log in not with the HANA, your own user ID and or your own password which will be provided to you. With that you need to log in. So once we have login here, we can go into the system and we can go into the status. So from here, you can come to know that which system you have logged in, which system actually it is. If you a little bit scroll it down, you will see here your schema. This is the schema where the whole data would be stored. All of your data for this application would be stored in SAP HANA DB schema in SAP HANA database. So I'm talking about now two different interfaces. The GUI is the interface which can be used by users, consultants, technical consultants. They can use. You are having a GUI with ECC also, and with S4 HANA also the GUI would be there which you would be able to use. HANA Studio would be used by your HANA admin guy, your database admins, your technical consultants, data modeler, These are the guys which will be going through the HANA Studio. For a functional consultant, you just need to understand what is HANA Studio. Because a couple of questions would be there in the certification exam. Nothing more than that. Okay, we'll not go into the deep into the HANA Studio, but as a functional consultant, what you need to know, only that part will be covering here. So functional consultant, HANA Studio is optional. So from where we can see the actual database where the data is sitting, you can see in your HANA database system, and this is the schema. I will also quickly show you here that if you want to know that which version actually you are working on, you can also check your version here. So to check your version, you need to click it here on the detail. And here you will see your version S4 core. So if you remember, I told you that application layer has been changed from APPL to S4 core. In some of the cases and in the certification questions and the books also, rather than mentioning a version 1709, 1809, 1909, it mentioned the version 100, 101, 102, 103, 104. So basically 100 is your 1511 version, 101 is 1610, 1709, 1809. So if some of the books or SAP content they are talking about rather than 1909, they are talking about S4 Core 104 version, it's both are the same thing. So we are on S4 Core 104 version. 104 is your 1909. This is the latest one. Now I know that what is my schema. My schema is SAP HANA DB. Now I am going it here to my catalog, SAP HANA DB, there is a schema. Once I will enter the schema, there are a lot of other technical stuff is there. We will not bother about that. What we are bothered about our tables, where the data got stored. So to show the some concept of HANA database, I need to show you the HANA Studio. That's why we have come here. Now here you can go. When you will click it here, you will see the multiple tables on the plus icon. You can see here the filter. I have already put it a filter as a MARD. Okay, you can right click here and you can find your table, or you can also put filters. If you want to search a Mara table, you can put a filter for Mara. You will be seeing the tables related to Mara here. So I will show you the example from the MARD table. Okay, so I'm putting a filter here. MARD. So this is our MARD table. So once I double click here, it opens the content. It opens the definition. So this is the definition of the table. Now I go into the runtime information. Okay. In runtime information, you would be able to see what is the size on disk. Okay. And what is the memory consumption. What is the main memory and delta memory consumption. Okay. If you remember the concept, our data is stored in persistent layer and in memory layer. So that are the two different layers you are seeing here, size on disk and the memory consumption. So what I am doing here, I am doing a right click here. And what I am doing a unload from memory. Okay, let's see what happens if we do that. So I have done unload from memory, then I will do a refresh here. So basically this will remove, you can see here, the data here down also, the data becomes 0. So now in memory, there is no data. The data is there in the persistent layer, which we call it as a warm layer as per the HANA database temperature concepts. Okay, so there is no data here. So if you also remember that what I have said when we were discussing our presentation, let me go to that slide. Yeah, this is the slide. So this is the user. When user read the data, it always come from your in memory, right? That's what we have talked about. Now let's do that same thing. Now user came in and he wants to read the data. So read the data is as simple as what we will be doing it here. We'll be using a transaction code SC16, which we generally use, consultant use to directly see the table content. So I'm going into SC16 and I'm going into my table MARD and I will execute it. So this is a training system where basically it has a limited memory which has been put it up. So it can take a little bit of time for some transactions. So it shows me the data here. Okay. Now if I go back to my HANA Studio and if I refresh here again, I'm not putting back into the memory, I'm just doing a refresh. You can see that the data is back in your memory. Okay. So the concept was that whenever user use the data, it always comes from in memory. So that one, this is the example where we have pushed the data into the warm layer, but when user has requested it, system has automatically pushed it up and the read is happening through in memory. So that is the concept I want to show you from the database perspective, that how actually it would be happening. Okay. If you understand that concept, I will take a quick pause to check if you have any questions before I move to the next part.
Hi, Parminder, Samrat here.
Yes, Amrit.
Yeah, is the same way it's work in case of cloud platform?
Yes, yes. Cloud platform also, it works in the same way. So cloud platform is, I understand what is your cloud platform. Your cloud platform is nothing but your HANA database. Rather than in your own hardware, you have taken a hardware from Amazon, AWS, or some third party. So it is hosted by AWS, but the function and feature would be same. That is your private cloud. We call it as a private cloud. None of the features, functionalities, which I am showing you throughout this training will be a different for a private cloud. Your on-premise system on a private cloud, everything would be exactly same.
Oh, thank you.
Okay, any other questions? If you don't have any other question, we will move ahead. Let me quickly check the chat window. No, we don't have any other questions, so let's proceed ahead. Okay, now I will be switching between into the system whenever I need to show you something in the system, or we'll be proceeding ahead with our explanations. So in the data footprint reduction, in our last session, we have discussed that the data footprint reduction can happen when we move to HANA, even though we have not moved to suite on, even though we have not moved to S4 HANA, we have just moved to suite on HANA. I hope with the session number 1 and 2, you would be very clear that what is suite on HANA. Now, even though if you have moved to suite on HANA, you can see that your data from 600 GB can be reduced to 120 GB. That is the 5-time reductions you can see. And how this 5-time reduction can come up? This 5-time reduction can come up with these concepts: the index concepts, compression concepts, and the column storage concepts. Due to these three concepts, you can see the huge amount of data reduction when we move to SAP HANA database. So that is the thing which we are going to discuss next. The first thing we'll discuss one by one all the three concepts. The first concept we are going to discuss that how a data would be reduced by using a concept index. Okay, before I go ahead and explain, I would quickly ask you if you guys let me know what is your view on the index. What is index and how index contributes in the data footprint increase or reduction? Anyone knows anything about the indexes? Although it's a little bit technical topic, not functional. But as a functional consultant, what do you understand about index? What is index? Let's this class little bit make more interactive. If you would be speaking, if you would be answering my questions, you would be learning more. Otherwise, you will get sleep.
Hi, this is Vikas.
Yeah, go ahead.
I think so. Index is a pointer which refers to any data or transaction, you can say. So this is my understanding. So it points to the specific any transaction or data. That's what the purpose of index. That's what I know. Thank you.
Parveen, from my side, the index is a combination of the row and the column of a table.
Row and column. Okay. Anyone else?
Parvind Tara here. I guess index is like summarize pointers of the list of summary or something.
Okay. Yeah. So basically, what is index? Index is nothing but index is the whatever all of three you have said. It's partial right information. I will get it completed. Index is we put it into the system, our system, to make search faster. So rather than explaining you in a technical terms, I will explain you in functional terms. Okay. Let's say, give an example, you are reading a book. Okay. On S4 HANA, simple logistics. I asked you information that tell me what is AATP. What you would be doing, what anybody would be doing, you would go ahead into the index of the book. You will find that AATP is at page number 467. You, by seeing this combination, that AATP at 467, you will directly jump to page number 467. You will get the information and come back. So this is an index in a book, right? So what this index in a book is doing, it is linking your key data with the key point where exactly it is sitting. So it is nothing but it is helping you to read and search the things faster in your book or in a database. So the same way it happens in the books, exactly the same way it happens in our database or in our table also. When we mention an index, okay, when we mention index, system would be storing this information, a pointer information by which system would be able to easily search your data. Let's say, give an example, your sales order table. That's its a VBAP table. The primary index, the primary key field is your sales order and item number. But if you want to search your data based on your plant in VBAP table, you try to search in any system where ECC system, not S4 HANA system, where the plant is not there as an index, you will see that it takes huge amount of time. But as soon as a plant has been created as a secondary index, you will see the performance has been improved like anything, and the results are coming very faster. Okay, so that's what the index does. Well, now I would put one more thing into it. Let's say what will happen if I say that I took this book and I have removed this index pages out of it. Now this is the book without an index. I go and ask same question to you. What is AATP? What will happen? You don't have index. What you will do? You will go to the page number 1, read it out, page number 2, 3. From page by page, line by line, you need to go through the information, and then you will be reaching about page number 44, 67, and here you will find the information about AATP. Will you come back from here? No, you will not come back from here, because you don't know that maybe there is some more information at the page number 600, page number 700 that you don't know. So you will continue and you will complete your book. Then you will come back to me and you will telling me what is AATP. That is the difference between working or searching in our database in any table with index or without index. Okay, so in this case, if the plant is not there as an index and you want to search information about a plant, then system would be taking a longer time, because it doesn't have a combination of your sales order, item, and plant. This combination system directly doesn't store. If you create plant as an index, then this information would be stored, and then you would be able to quickly find your data. Okay, so now I hope that with this explanation, you would be able to understand what an index is. Now the second question comes that what is the linkage of an index with the data footprint? Now you can see that, you know, that at the start of the page, this index is, let's say it's a 20-page index, which is giving you that information. So what is this 20 pages? Whether this is 20 pages, are there any worth to this book? No, it doesn't have any worth. The worth is the information. This is the indicating to the information. This is helping us to find the information faster, but this is not a source of data. Source of data in the another pages, this is just an indication. So that is adding few additional pages in your index, in your book. So that is the additional footprint which you carry in your database by creating additional indexes. So what happened right now, I am asking the information about AATP. Then I asked that, okay, tell me, let me know what is ABC, alternative base confirmation. Or you would say, okay, in some day I need to also search about ABC. So I need to add more page about ABC. I need to more information about ABC and the page number. So I need to increase 2 more pages here. Then I need to say that, okay, tell me about the tiebreaker logic of ABC. Then you said, okay, that search can also come up. So I add few more pages. So by adding this all information to make it faster, your pages will start increasing in your book. Okay, the 20-page index would be converting into 50-page index. So total books is 600 and 50 pages is only index. That's how the index contribute in your data footprint to increase the data. So what happened technically, whenever you create a secondary index in your system or your technical consultant creates it, at the back end of database, your main table will be get associated with one more extra table, that is index. So if you have created 4 more indexes, which means your main table is this, and this is linked with 4 more tables, which is an index table, which is storing a key information. So every time you create an index, a new backend table has been created which store the information. So that's how the index helps you to search the things faster, but it increase your data footprint. Now, what happened? The other thing, whether index makes you slow. Index, if you have a lot of index, it can makes your write performance. Write performance means when you are entering a data. When you are punching a sales order, that process can become slow. How? Because when you commit anything or when you punch any of your sales order, it goes into the main table, and with the program logics, all of your index table are linked. So when you do the commit, the information need to go into your main table, plus information need to also pass through in all of these index tables so that the data can be stored. So the more and more index table if you are having, it can slow your performance of write, although it can help you to increase your read performance. So this is index. This is the impact of index on the data footprint. Now, how index can help out? When we are saying S4 HANA, we say in S4 HANA, no index is required, or I would say no secondary index is required, because based on the column concept. So if you are having these number of fields, this is your order, this is item, and this is plant. Each field act as an index. Each field has the information which act as an index. So each field actually act as a, or each column you can say actually act as a file itself. Okay, each column is a file itself which is already having an indexing information, that how it is linked with the order number that is already there. This concept is called inverted index. This we'll be discussing in our next topic when I will be explaining you about row and column data structure. We'll be discussing about that. Okay, so this is index, and now I think you would be able to understand how data footprint can be increased with index. Okay, what index helps and why indexes has been removed from HANA databases, and because of that, it will our data footprint would be reduced. How the performance would be still high, read performance would be still high, is based on the inverted index concept, which we are going to discuss. We'll take a quick pause to check. If you have any questions, you can ask it now.
I have a question. I couldn't understand the difference between that secondary index or a main index. Can you just explain it more?
See, primary index is given by SAP, which is your key field. Secondary index is the additional fields which you add or which you activate in your table as an index.
Okay, cool. Yeah.
Those are the secondary index. Any other question, guys?
Hi, Parminder, as you say that as much as index we'll be using, so it will reduce the data footprint. So in that case, where while in performing the any code, so it is better to use lesser index as per that.
If you are in ECC, you need to make sure that you are not creating a lot of indexes. You need to create only significant indexes, which is required to make your search faster. For each and everything, you should not create an index. Okay, but significant indexes are required in ECC to create it to make your search faster. In SAP S4 HANA, you don't require a secondary index to be created, because each column, each attribute itself has an index information. separate index information is not required.
Okay, so this concept which we are using in ECC currently, so that concept is overridden in S4HANA.
Correct, correct.
But many times since I am not having much knowledge, but I think this particular due to the lack of knowledge in technical consultant, they are using this concept in ECC in S4HANA also. That's why many reports, any customized reports is also running slower in S4HANA. Means that is a code concept. I think they are while writing the code, they are using the existing ECC concept. That's the problem, I think.
Yes, you are correct that the people who are still not upgraded and who still doesn't know that what is the advanced functionalities features are there, and they are using old code methodologies, there are chances that if they use the new technologies like a CDS views, the performance can be much faster in HANA with SAP S4 HANA.
Okay, okay, thanks
Yeah.
for that.
Yeah, one question, like when we migrate from like EC6 to S4HANA, at that time the like all the secondary indexes, what happened to them? That it's they just migrated to the new version, or they or S4HANA just removed them automatically? Can you just explain it?
Yeah, so to explain it, I'm going into the system. I'm going into the table DD12L. So this is the index table. So if I will go here and I just execute it here, you will see here that the multiple indexes which you have put it, you would be having here that these indexes has been for this database, it has been excluded. And for what database it has been excluded is HDB. For HANA database, it has been excluded. So what happened that SAP also provide the technical consultant the reports which they can run and identify that what are their indexes which which they have created as a secondary and which would not be required in SAP S4 HANA, and then they can switch off them by using this index. They can exclude them for the HANA database system. So that need to be done. So there are some reports has been given by SAP for technical consultant. They run, analyze the system and do it. Whatever the SAP indexes are there, as soon as you move to HANA or you switch to HANA, system automatically exclude those database for the HANA database system. Although there would be some indexes which you will find still be there, they are the technical reasons. Some indexes they have kept it due to the conversion process. But otherwise, the maximum indexes you will see, it has been excluded. Do we have any questions before I proceed ahead? Okay, if you don't have any question, I will proceed ahead. Now we will be discussing the concept of inverted index. To explain that concept of inverted index, what I would be explaining first, we'll be discussing row and column data structure. So I will be taking an example where we'll be discussing with this example we'll try to understand inverted index concept, that how we have removed the indexes in SAP S4 HANA, but the still performance would be good. Okay. Now let's take an example. So I'm taking example first for row data structure, that how the data has been stored in your row data structure. In last session, a lot of people, 2-3 people have asked the question related to row and column data structure. So please be focused here. The concept is little bit typical or little bit difficult. If you will little bit concentrate, then only you would be able to understand. It's a little bit technical concept. So we have a sales order number. Then we are having product. We are having customer. And we are having quantity. I will just take a small example here. with 4 line items. So let's say my sales order number is 1001, 1002, 1003, 1004. My product is Coke chips. Coke chips. My customer is Hypermart. Then let's say Amazon. Hypermart. And then I have a quantities. 100, 200, 300, 400. So this is the example, right? So what happened in the row data structure, how the data is stored in a sequential manner. 1001, Coke, Hypermart, 100, then 1002, chips, Amazon, 200, 1003, Coke, Amazon, 300, and continuously. That's how the data would be stored. And let's say I put a query here on this data that what is my open order quantity for Coke, which is my basically product. And in this, let's say I don't have an index. So what would be happening? The system will go field by field, row by row to search all of the things. It will find I have a Coke here. This is my quantity. Then again, it will find by searching, it will find I have a Coke here. This is the quantity. It will not stop the search here. It will continue till the table end. And then it would be coming back that the total quantity of open orders for Coke is 100 plus 300. 400. So that would be the outcome coming with this row data structure without index, where basically system need to read a lot of data and then come up with the output. Now I would show you that how the data is stored in how the data has been stored in our column database structure. So I'm taking the same example, sales order, product, customer, quantity. Now in this, I have a sales order number 1001, 1002, 1003, and 1004. These are my sales order. So what happened in the column data structure, it only store the unique values. The column data structure would not be storing the values which is repeating again and again. So it do the huge compression of the data. So now you will see that in this example, my Coke is repeating, my chips is repeating. So what system will record here? System will record Coke. System will record here chips. System will record here Hypermart. System will record here Amazon. In this example, I have a different quantity, so system will record 100, 200, 300, 400. You see here, this is the data which system has not used. This is your data which system has saved. It's a complex data. In this example, it will look very little. But in generic, if you know about the SAP tables, any tables you pick it up, it would be having a different 50, 60 columns. And what is the data out of this 50, 60 columns, which is unique in each of the line item? Let's we talk about the sales order table, VBAK table or VBAP table. Your sales order number is a unique, which will be different for each line. Your sales order items would be repeating, your customers numbers would be repeating, sales organization numbers would be repeating, division would be repeating, and heavily repeating. Okay, so what happened in the row data structure? System store them again. But in the column data structure, it follow, even though the data is not stored, technically the data is not stored, which I have written it here. Technically, it's a little bit different concept. I will put it down here, but it doesn't. The main thing is that it doesn't store the repeated values. If a customer is having a 200 orders, Amazon, as a customer number in the database, it will be stored only once. So once you're having a 2 or 3 years of data, you would see that the 1,000 of orders would be there for a customer. So rather than repeating those all values and all the attributes, it doesn't repeat. That is the beauty. That's how we will be able to reduce the data footprint by doing this column data structure and by doing these compressions. Now the question comes that if this data is not stored, then what is the linkage between this? How this data is linked? You all might be having this question. How the data would be linked? Okay. Now the data would be linked with the concept of inverted index, where you will see that each column is having its own index. So now what happens actually, how the data is stored. I'm writing here the example again: sales order, product, customer, quantity. So in S/4HANA, there is a concept of library concept, where basically it's not S/4HANA concept. I would say it's a HANA database concept. It's at the back end of the database. Even we cannot see it. What it does, it gives a pseudo number to everything. So what system would be doing? System would be giving a number. Coke would be assigned a numeric number 1. Chip would be assigned a numeric number 2. Okay. The same way the hypermart would be assigning another number 1. Amazon would be assigning another number 2. And this also would be assigned to a number 1, 2, 3, 4. And this also 1, 2, 3, 4. Okay. To having an understanding purpose, and there would be a record ID, which is again a numeric number for each line item of the table. So record ID is R1, R2, R3, R4. That's how at the back end the data has been structured. These numbers would not stored in the database. Database stores some another numbers. To have a better understanding, I will write the same thing here also. R1, R2, R3, R4, and this is linked with the pseudo number 1, 2, 3, 4. Coke is 1, chips is 2, 1, 2. This I am just writing for the understanding purpose. This is 1, this is 1, this is 2, 2, 1, 2, 3, 4. Now see how the data would be stored, how the each column would be stored. Each column would be referenced to having a this number. So sales order and quantity is having a 1-to-1 linkage. So how the sales order and the quantity would be stored? 1, 2, 3, 4, and the linkage would be R1, R2, R3, R4. Quantity is 1, 2, 3, 4. The linkage is R1, R2, R3, R4. Now concentrate. Okay. If you will lose here, you will not understand the concept. What will happen in the case of Coke? Coke is here 1, and it is linked with Coke. If you will see here, Coke is linked with R1 and Coke is linked with R3. So that linkage system will maintain here R1 and R3. Chips 2. Chips is linked with, you will see here, chips is linked with R2 and R4. R2, R4. Customer, Hypermart 1. is linked with 1 and 4. You can see from here. Hypermart is linked with R1 and R4. Your Amazon is linked with R2 and R3. So this is how at the back end of the database in the column data structure, the data is stored. That's why we call it that each column is having an index. So this linkage is there in each of the column. That's why you will read everywhere that each column in the column data structure in SAP HANA database act as an index because they already have the indexing. So now what I'm going to do, I'm going to put the same question to this database. What is the open order quantity for Coke? Let's see what answer we get it. What is the open order quantity for Coke? The system first checked that what is the number for Coke. Coke is having a number 1. It doesn't go row approach, it directly go to the product column. Directly this column system will approach and system will understand from here 1 is linked with R1 and R3. After having this information, it will directly jump to your quantity column. It will read R1 is 1, R3 is 3. Then it will read from here 1 is 100 and 3 is 300. It will sum up 100 plus 300 is equal to 400. So the answer which has been told in both of the cases is same. Answer is same 400, but approach is different. In the second approach, you might be thinking that system has gone to the multiple places. But actually, if you will see that yes, system has gone to multiple places to get the answer, but total amount of data which system has read to reach to the 400 is 10 times lower or even sometimes hundreds times lower or 1000 times lower than the data it read to the row data structure. In row data structure, it goes field by field, column by column, everything it reads. Here, I have just put it here 4 columns. Generally, 4 columns would not be there. Any tables would be having almost 50, 60 columns. Okay, so it will skip all of this data. It will only focus on the query which has been asked. It has skipped this data, full data. It has skipped this data. It has only gone to the columns where the query has been asked. Okay, so that is how, although the indexes has been removed, but indexes are inbuilt. We need not to create this inverted index. These are automatically created. These are inbuilt with SAP HANA column data structure. And what another functionality and feature we will be getting it from here, we will be getting another functionality feature called massive parallel processing. How the massive parallel processing will come? Because now each of this column is having its own index. So each column acts as a file. So in row data structure, if you have a multiple queries to a table, it goes in a sequential way. In column data structure, if you have a 2 queries, one query need to work on the product, another query need to work on the information for customer. Both can act parallelly on this table and go to the different columns, read the data and provide the parallel results. That is called massive parallel processing in SAP S/4HANA. That also helps to increase the performance, increase the read performance without indexes. So I have explained the concept. I will take a quick pause here to check if you have any question.
Hi, Parminder, can you explain that massive parallel processing once again?
Sure. I can explain it. So let me take a screenshot of it. Let me save it and then I will explain you the massive parallel processing. Okay, so the question is massive parallel processing. So what is happening here, if you will notice here, in this concept, earlier when we are having information, this linkage is not there. If you work on the product itself doesn't have any linkage to the sales order number. Customer doesn't have any linkage to the sales order number. Direct linkages are not there. Now what is happening here, each column, if you will read, I'm reading only this column product. I know that this product information, this material number is linked with the specific records. Okay, is linked with the specific record. So I can have a query which can work on this column, technical query, and then it can come with the output that it is linked with R1 and R3. Any another information is required, it can jump to another column. In row data structure, what happens? Your queries work on your row data space structure in a sequence. Just give you example, if you have two queries, what is the total open sales order for Coke? That is the one query. Second query is, what is the total number of orders for customer Hypermart? Okay, so this both queries can work parallelly. One query can work on your product, the same example which we have said. Second query can directly come here on customer. It will say that Hypermart is 1. It go into this column 1. It will just count it here, R1, R4, 2 is linked. It will come with the output as a 2. 2 orders we are having for Hypermart. So that is parallel processing. If the same thing happens in the row data structure, first you will get an answer 400, then system will start the processing of the second query, then you will get the answer 2. Here the answer 402 you will get parallelly. Any other questions, guys, on this concept? Okay, if I am not hearing any other question, I hope you got this concept. If you have not got, don't worry, it's a little bit typical concept. Please go through the video once it's there, listen to the video again, and then you would be able to completely get the concept. I have just explained you the one way of data compression. HANA has a multiple ways to do the data compression. Just to give you an example. And this, with this data compression, the reduction which you can get is huge. Huge reduction you can get it with this concept. If the big number is there, let's say 5, 5, 5, 3, 2, or multiple 5s are there, 1, 4, 7, then it has a concept. It's a multiple. There are many concepts like this. The HANA admins knows more. It doesn't store like this. This 555, it just say that it put a notation here that prefix has been repeated. Okay, it put 5147. That it puts. Okay, so there are the multiple, these kind of concepts are there, which has been used to compress the data, by which you would be able to get your data compressed, and then you would be able to see your data footprint reduction. So here we have discussed the three things. So what we have discussed so far. So far we have discussed that we were having somewhere around 600 GB data. We were able to reduce to 120 GB. And how we have done it? The first concept we use is the index. By removing indexes. By removing indexes, the backend tables will get removed, which is created at the backend of the database. Column data structure. Inverted index concept. And compression. These all four together make sure that data reduces, but still performance increases. Now you would be able to see that this column data structure is having a major effect to increase the performance. The removing of indexes is having a majorly is doing your reducing of data. Inverted index is also basically working to increase your performance with the reduced data. Compression of data is acting to reduce your data footprint. Okay, this is we have discussed, and by this we were able to move from 600 GB to 120 GB without changing any data model. So far we have not done any changes in the data model. Now we'll go to the next concept where basically we'll switch to S4 HANA, and then we'll see how the data footprint will reduce with S4 HANA.
Hey, Ravinder, quick question before you leave from the screen. Will this follow sequencing? Will the sequencing follows all the time, or how does it work?
Which sequencing, sorry?
The index, column, data structure, inverted data, compression of data.
All the time, correct. It follows all the time.
Okay, it follows the same sequence all the time.
This is not a sequence. 1, 2, 3, 4 is not a sequence. It's actually the bullet points. Index, column, inverted, compression of data is not exactly sequence. Many things happens parallelly in your HANA database when the data gets stored. It's not a sequence. It's just a bullet points, which I have mentioned. The data compression generally happens at the later stage. Any other questions, guys, before I move ahead? I will go into the system and we'll see that concept of we'll see this concept of compression, and how the data get compressed. We'll be able to see through the HANA Studio, which we have discussed today.
Yeah. So Parminder, sorry, Pramod here.
Yeah,
When you say data compression will occur in later stage, does it mean before the storing of data, right? Like everything will be parallel, but compression of data will be later, but before storing the data, right?
the compression of the data happen at the multiple stages. This is a good question. Let me explain in the next slide. So they have also put it one more concept, which we called it as a delta and the main storage.
Okay.
That is also one of the questions which has been asked in the certification. And that is another thing, you know, that how systems SAP makes sure that concepts we have discussed, that increases your read performance, right? How about the write performance? If the system is busy putting this inverted index, putting this pseudo numbers, and then compressing the data, then your write performance can be reduced, because all of these things need to happen when the data got written, right? So to do that, SAP HANA has put it one more concept here, which we call it as a main and delta storage. This main and delta storage both would be part of your in-memory. So actually, technically, what happens, your each table, each and every table, and you neither technical consultant need to do anything, nor functional consultant. Each and every table is divided into two tables. Main table, first I will write, sorry, delta table. And main table, any table, your VBAP table, VBAK table, EKKO table, sales orders tables, purchase order tables, any table where the data is there. If you talk about, actually technically in HANA database, it's stored into the two places, delta storage and main storage. Okay. When a user comes with the write command. It need to store any data. It need to do some commit transaction. What happen as soon as the transaction get commits, where it goes? It goes to the delta storage. Okay, and after some time, that automatically your HANA database automatically determine when it has a significant data in the delta storage, it automatically moves data to the main storage of the same table. It's the same table. Technically, this both is a partition of your VBAP table, technically. Okay, so once data stored into the delta storage, and after some time it moves into the main storage. Once it moves into the main storage, it gets clears from the delta storage. Why this concept is there? Because the compression which need to happen, the major part of the compression is done when the data is transferred to the main storage, because that can be a resource intensive thing which can little bit reduce your write performance. To make sure that your write performance is not reduced, first it goes into the delta, and from the delta then it moves to the main. In delta also there is some compression happen. Some compression in delta also happen, but the 90% of your compression would be happening when the data comes to the main storage. At the same time, if a user comes up with the read command, now he need to read something, he need to get the data, output of the data. From where he would be reading the data would be read from both always. To give you always the live data, the read part, when it goes to HANA, it always check both the data in the delta and the data in the main storage, and then it gives the output. So a mapper is writing a program, they would be referring VBAP. You are running a SA16, you would be referring to VBAP. Technically in HANA database, the data is separated into this delta and main. Okay, and this is how the compression would be happening. Any other questions, guys?
Is there any logic written for compression, or is it just built-in functionality?
It's a built-in logic which has been put it. There is a 6 or 7 different logics which has been put it in for compression. So one of them I have explained you that suffix it, reduce it, prefix it, reduces. So that kind of 6, 7 logics they have put it, which automatically system determine that for which kind of data, how the compression need to happen. So that is inherent to the database, which is written into the HANA database system.
Thank you.
You mentioned certification examination questions around this, but what kind of question is asked typically?
So basically, the question which is, I don't remember the exact question, but the question related to that in HANA database, which concept is used to make sure we have a good write performance. So this delta and the main storage concept has been introduced to make sure our write performance is good. Okay. Otherwise, the previous concept which we have discussed, the column data structure or your inverted index concept, that
Your voice is gone, Parminder.
Yeah, I think the voice is muted.
Yeah.
Guys, are you able to hear me now?
Yeah, now it's fine.
Yeah.
Okay, thank you. Sorry, I don't know how my voice has gone. Sorry, what was the question? Can you please repeat again?
You were talking on certification questions.
Yeah. So certification question which has been asked, that which technology or which segment has been used to improve write performance in the HANA database. So the delta and main storage concept has been used to improve the write performance of HANA database. Any other questions, guys? Okay, if you don't have any other question, I will move ahead. I will quickly go into the chat window, not chat window, sorry. I'll quickly go into our server and we'll try to see few concepts related to that. I need to reconnect. Okay, so to show you that concept, I am in the same HANA Studio, and here you can see I'm having my table MARD, which I have gone through. I have gone into my schema. I have put it filter on the structure, and I have went into the MARD. And in the MARD table, I can see here the data in the main storage and the data into the delta storage. You can see main storage and you can see delta storage. That is the concept which I have just explained you, how the data is stored between two different storages. And you can right click here and there's an option. So these all options, there's no need to do it. It's a job of a HANA admin guy, but he can click it here on perform delta merge to transfer the data from delta storage to the main storage. However, SAP doesn't recommend that to use this function. SAP recommend let HANA has its own logic to transfer the data and let it be done by its own automatically. Now I will show you the compression part. So you would not be able to, visualize that great a compression here, because this is a very new system which has a very few data, only few 100-line items is there. So when you, the same thing which you will see in the system where the 10,000 or even 1 lakh line items or 100,000 line items are there, there you will see that how big the compression of the data can be. So here you can see that for each column in the MARD table, what is the size which has been stored in the main storage and what is the size which has been stored into the delta storage. So you would see here that main table size is just 1 KB, 2 KB, 3 KB for most of the columns. But when we'll go to your MATNR, so in MARD, the mostly it would be the materials, okay, which would be mostly it would be unique, not 100% unique. Material can also repeat, but the material is the one which is repeating again and again. So when you will see the material repeating again and again compared to the another columns where it has a 2 KB data, 1 KB data, it is having a 7 KB of data in the material. So it's the same way if you will go to your VBAP, VBAK or your purchase order tables, where the sales order number or purchase order number is a unique value, you will see that the data storage for that column, okay, for that attribute is more compared to a sales organization which is keep on repeating every time. Okay, so but to give a, so this is just a small difference. You will see only 5 KB differences there. But if we have a significant amount of data, the more data we are having, the more compression you will see here. The more difference in the system you will see. Okay, so that's how the data has been compressed, which you can see here. System also show you the compression ratio here, that how much, with what percentage the data has been compressed. You will see 90%, 50% compression ratios, which is a huge compressions, which has been done by system. Okay, so that was the concept I have quickly shown you through the HANA Studio. Now we will be going into our second part. In the second part, we would be going into SAP S4 HANA. That when we go into the SAP S4 HANA, how the data footprint would be further reduced. Now you would be hearing about the data model got changed, and because of this, data footprint reduction happens. That concept will come now. Okay, before I move into it, if anyone has any question, please go ahead. Okay, if you don't have any questions here, I would be going ahead and explaining that how the data footprint will be further reduced. So this data footprint reduction only will happen when you move to S4 HANA. If you have just moved to your HANA database and the data model has not been changed, this footprint reduction will not come into the picture. Now, now what has happened here, the major concept here, which would be there to reduce the data, is we are having a lot of data which we are stored as a aggregate data. Aggregate data means we do the summation, we do the calculation, and we store in a table. Again, why we do it? Because our existing database is not that good, which can do on-the-fly calculations. On-the-fly calculation means when user required, you do the calculation and you provide the data. We cannot, our existing database which is there with ECC cannot do. But S4 HANA database now can do on-the-fly calculation. So there is no need to have a tables which just stored the aggregated data. That kind of tables or that kind of aggregated data we need not to store anymore. With that concept, we are removing some tables also. So we are having some tables here, you can call aggregate or index table, VAKPA table, okay, or VAPMA tables, which is basically having a combination of your orders plus your partner function. That kind of information is there. Although the main information is there into your VBAP and VBAK tables. Okay, the main information is there. I'm not going into the very detailed of the data model simplification. When we go each module by module, we'll again discuss that what tables has been removed. But at high level, that what is the impact of data model changes we are discussing here. So that kind of information is stored, which is just aggregated data. Your VBOX is completely your rebate table, which is a complete index between your invoices and agreements. That data has been stored here, and that data can be huge amount of data. Even SAP has given examples where basically the people or the businesses who are using rebate functionality intensively, this VBOX table, by only removing this single table, the 20% data has been reduced. So the 5 terabyte data has been reduced by 1 terabyte, keeping by only this single table VBOX. That huge that aggregated data can be in some systems. Okay, so if you remove these parts, you would be able to reduce the data footprint further. Some of the parts where basically your header and line item statuses has been stored in the different table, that has been combined in your header and item tables. Your finance data model has been simplified, but the most major simplification come into your inventory management. Okay, into the inventory management. So why there's the most number of changes into the inventory management? Because we are having a new table here, which is called MatDoc. And actually two tables we are having, MatDoc and MatDoc extract, which we are calling for inventory. It would be having a single source of truth in MatDoc table. Okay, in many forums and places you will read that now the single source of truth is MatDoc. It's a two tables actually, MatDoc and MatDoc extract. We'll discuss that what are the differences in these two tables. So your MKPF table, MSEC tables would be reduced. Your multiple tables which stores the aggregate stocks will reduce. Your multiple tables which stores the historical stocks will get reduced. Your tables which has the data combined, let's say your example of a MART table. MART table has your master data which stores that material, plant and storage location combination plus stock also. So stock is your transactional data and this is your master data. So SAP is also simplifying data models. They are separating master data tables from the transaction data. So these tables has not been removed but modified to only store your master data but not the stocks. So MARD table no more is having your stock information. Okay, so these are the changes which is coming up. Before I proceed ahead, I will ask you a question to you. What do you think? What is stock? Stock is transactional data, is a source of truth data. What is stock? Or if it is not a source of truth, what is stock and how does it calculate it?
Stock is a transitional data which ability of the movements of the materials, systems update and gives the result.
Okay, that's very correct statement. It's basically based on the movements it gives the information. But if that is the case, why we store the stock data into the multiple tables? Why do we need to store the stock data in the so many tables you see here? Most of the tables, they are around in more than 26 tables are there in ECC which store the stock information. Why?
Dependency, basically,
Okay, dependency of what?
of stock or a particular material to get a finished product or whatever it is, any scenario.
Mm-hmm. Okay. Okay. Mm-hmm. Anyone else has another viewpoint before I explain it?
Yeah, in SAP we keep the stock in different tables in order to perform the activity when we are doing any transaction.
Yes, to perform the activities we put into the tables. That's a very correct statement. So let's discuss what happened with the stock. Why with the stock SAP is able to remove a lot of information. So we said that stock is never a source of truth. So what is the source of truth? Your source of truth is material document. Okay, so let's say when you start a system, from where stock comes, you put a 561 movement, upload the stock, and then multiple transaction happen, multiple material document get posted, which either increase the stock or which reduce the stock. Okay, so there would be material document which can have a no impact on stock. Some can increase the stock and some can reduce the stock. Your 561 movement upload of stock will increase from 0. Let's say you uploaded 100. Then you have consumed in your production order with 261, you have consumed 200 stock. Okay, then what would be your stock quantity? 100 minus 200, So not 220. 100 minus 20, your stock will become 80. Then you are having a purchase order. Against purchase order, we use movement type 101. We receive a stock of 50. Okay, so what would be my quantity now? 80 plus 50, 130. Then I did my sales order posting for the same material. I did 601 movement, issued the stock of 70. 70 I have issued. Then my stock would be 60. So stock is keep on changing. If the parameters keep on changing, with every material document it is keep on changing, why does it make sense to store this in a table in database? It doesn't make any sense to store the stock in the database tables, but we need to do that. Why we need to do that? Because these material documents can be in thousands, not in thousand is wrong, it can be in millions. In a big organization, there are thousands of postings happens on everyday basis. Everyday basis, there would be thousands of material documents which would be posted, which would be impacting your stock. Even every second, there is a material document which is getting posted. In current database, our ECC database is not that capable that if I need a stock information, I ask the system, it goes into the system, do the calculation, and give me the information in the real time. This concept, we call it on the fly calculation. So this is called on the fly calculation. Okay, so our system is not capable enough that it can do the on the fly calculation whenever we ask it. It can go to the material documents, it can do the calculation, and it can give us result back. It doesn't have that much of capability. That's why we are storing a stock into the multiple tables. It's nothing but aggregated data. We are storing it into the multiple tables, so that whenever in any function, whether it's a ATP check or any another function, MMB, stock check, stock has been checked in multiple application in multiple times. At that time, I need not to calculate it again. I will be having a ready information which I can take it and then use it and execute it. Okay. Now, can anyone tell or get an idea that in the ECC system, when we have a material document, when a user posts a material document, how many different tables get updated? Any idea?
I think the stock consumption accounts.
There are two
I'm just
documents
looking for a number. How many different tables can be uploaded? Just as a number. 5 tables, 10 tables.
3 to 4 tables.
I think MARD, MVR, yeah, 2 to 3, yeah.
Actually, anyone has any other answer? Okay.
Account determination, okay, not, yeah.
Roughly more than 100 tables.
Yeah, T0, yeah.
More than 100 tables get updated when you do the posting of material document. Your MSEC table, technically if we speak about, your MKPF table, and the small index table which is associated with them. And all of the tables which have a stock information, your MAR table, MARC table, index tables associated with them, then your special stock tables, Then a lot of tables are there for your historical stock, their index tables. On top of that, if your ABAPer has created more tables for any calculation, any aggregated table, and whenever ABAPer creates this table, they for sure put some indexes to it, index tables. So this everything will get updated in a single shot when you commit the data. All these tables need to be updated when you commit data which need to do anything related to stock. Why we are updating so many tables? Only because our read performance is very poor from the database. So because of the database, what happens? Our data model has become very complex. Programming has become very complex. A lot of programming logics has been written to make sure all of these tables are in sync and all of these tables get updated. Your throughput of writing a data becomes slow because so many tables need to be updated. The locking of the tables become a problem because it takes a little bit of time to get updated all of these tables. So the tables need to be locked. So it created a lot of problems. And what is the source of all of these problems? Because my reading performance is low. That's why I'm storing so many tables. I'm writing so many programs. I need an intelligent ABAPers who can understand these data models and then do any enhancement whichever I require in this complex data models. So SAP think that if we are coming with the HANA database, which is having an immense power of parallel processing and on-the-fly calculation, the stock which is making the data model so complex can be simplified, and we can do all the stock calculations on the fly. On the fly means any transaction who requires a stock, whenever you will execute it, at the backend system will go to the material documents. It will calculate the stock. It will give back you the results on the fly. You click on the execute and the result come back. Everything would be calculated on the fly. And why we are able to do it? Because this is HANA database. This is a database which work on in-memory concepts with your row, with your column data structure concept, with inverted index concepts. With all of this concept, it gives us immense power to do the on-the-fly calculation. So what is going to happen? What is going to happen in, or let me put it here itself. What is going to happen when these data, when a material document is posted in S4 HANA? What table will get updated? It updates two tables, MatDoc table, and at the same time it also updates MatDoc extract tables. So these two tables will get updated as soon as any document which is related to stock get posted. Whether MARD get updated? No. Do it has index tables? No. Do it has historical tables which got updated? No. MARC tables? No. Only two tables. From 100 of the tables, SAP has reduced to the two tables which get updated when the stock get posted. Okay. And then what happens when user asks for information? Okay. When user asks for information, they have written a CDS views. CDS view is a core data structure view, which is nothing. Don't get confused with the name. It's just a program logic, which is written ABAP on HANA. Now this CDS views goes into this table, do the calculations, get the stock back, and feed it to your user. That's happened through the CDS view. This concept is also called push down methodology. People who has attended the session number 1, you will remember one thing, that when we moved from R2 2-tier architecture to 3-tier architecture, we said that we have reduced the load from the database by putting an application layer, and now the calculation happens in the application layer. When we are moving to S4 HANA, we are still on the 3-tier architecture, but with this CDS view, what happens? CDS view is written on application layer, but it pushed down your logic of the calculation to the database. So now what happened? Earlier what was happening, the database provide the data to the application layer, and application layer does all the calculation. In CDS view, what happens? It goes to the database, it consumes your HANA database to do the calculation, it brings the stock back to the application layer, and from the application layer, it feed it into the directly to your presentation layer. Okay, so CDS view are pushing down and using a SAP HANA capability. It's written on ABAP on HANA. It's using SAP HANA capability to do the fast calculation, to do the on-the-fly calculation. That was one of the participants were asking that the programs are still not that fast in our S4 HANA system because the old principle of the coding has been used. Any place where the calculation need to be used, the statement is very right. ABAPers and the technical teams are not upgraded. They're still creating aggregate tables, which is not required. They're still writing a normal logics on ABAP, which takes the data from the database to the application layer and do the calculations, summations, and writing algorithms on the application layer. Anyhow, they need to use the CDS views. If they want to bring any data, any calculation, filtration, summation, aggregation need to do, they need to write a CDS view, which get the data from the HANA database, do the calculation at the database itself, and feed the final result to the application layer. The performance would be better. That's the concept in your S4 HANA. Okay, and this is the way your technical architecture of the data model is changing. I'm taking a quick pause to check if you have any questions before we proceed ahead.
Yeah, Dharmendra Pramod here. So basically, I was just curious here, as a functional consultant, we often do the queries, SAP queries like SQ00, like SQ02, wherein we join different tables. So I was just thinking in S4 HANA, so is that query concept still there? Because when we say the tables have been drastically reduced, so how that works, like the query part?
Very good question. So I will answer that question, how the query part works. Okay, query parts would be still be working. Okay, so first let me ask you a question to everyone. Okay, then with that explanation, that your question would also be answered. So my question is, now what will happen if you go and check your MARD table? Do MARD table has stock inside it?
Yeah.
Or not? Whether you will be able to see the stock or not? Anyone would like to answer it? What would happen if you go in FT16 and see the MARD table?
It would have the computed stock or the same SAP stock. That's your question, is it?
Whether it will have a stock or it will not have a stock.
It should still.
Yes, guys, one by one.
Sorry. Yeah, it should still have the stock.
Okay. Anyone else?
Parminder, you are talking about that whenever you do the posting in MARD, there will be stock, or you, what's your question basically?
My question, you go into SA16, you execute MARD, the stock will be there or not?
Yeah.
Stock will be there. Okay, fine. Yeah, answer is right. You would be able to see the stock. So the question is, what would be happening if in MARD you go and check your stock in SA16? Okay, or any table you execute where we are saying that the stock information is not at all there, and you are executing this table in SA16, whether the stock would be there or not. So what happened in that case is anyone who execute MARD, whether you execute through SA16 or your programmer executes the MARD table, or in your queries you have combined a table MARD. Okay, anything which you are doing here, what SAP has done, MARD, they link it with all the tables where the information has been removed. The definition is there. Definition they have not removed, and they have put it a proxy object to it. It is now attached with the proxy object. This proxy object is attached with the CDS view. This CDS view is having actually multiple CDS view. And finally, it gets data from maddog_extract. Okay, so the maddog extract system, this CDS you do the calculation, and then you would be able to see the stock. So the answer to your question is any queries or which you are using, if you use the same tables, SAP has not removed the definition. So all the queries would be still be working. But if your query is doing some complex computation, or the complex data is there, it's preferable, and you need to use it on repeated basis. It's preferable you ask your technical guy to create a ABAP program, to create a ABAP on HANA program, to create a CDS view, which can be linked to your transaction or a Fiori application, where those data can be combined. You would be using a power of HANA database. From the database, the data would be combined, aggregated, summarized, or calculated, and give it to you. So small query is not an issue. Anything which need to be used repeatedly, little bit complex query, you need to ask your technical team to write a CDS view for you.
With this, what happens to concept of infrastructures? Like if there are reports which are generated every month, open order or number of invoices and those kind of a thing. So
infrastructures, SAP has said that it would be outdated. It would be replaced with the CDS view, but it is still there, because each and every CDS view, SAP has created thousands of CDS view. I have seen a very good progress from 1610 to 1909. If you'll go through the simplification PDS files also, you will see huge number of CDS view SAP is releasing for that kind of same information which was provided through the infrastructures. As of now, it is there, but in future it would be replaced completely by CDS views.
Thank you. Thanks, Parminder.
Yeah, sure.
I have a question. Like this CDS view is on. You're saying that it's on application layer. So what's in the memory? Is that memory layer or application? Because I thought that it was memory.
Yeah, so CDS view, what happens? That's a good question. It's also asked in exam also. So we have an application layer. This is your application layer. This is our HANA database. In the structures, when you will see, you will find CDS view is written like this. And this is your presentation layer. Now this application layer is also a database. To use S/4HANA, this application layer database can be any database. Not any database, but they have mentioned the database, but it can be other than HANA database also. It's not mandatory that your application layer should also be on HANA database, although where the data has been stored, this is mandatory to be HANA. Okay. So what CDS views do, CDS view try to reduce your load in the application layer. It is written here, but it is passing your commands to the HANA database. So any application layer logic, what it does, it passes the commands to the database to get the data. But CDS view, what we do, we get the data plus it's a SQL language has been used, so we can get the data plus we can also do the calculations in the CDS view. And when we do in the CDS view, this calculation, it use the resources of your database, not the application layer resources has been used. So here the data will be getting out, calculation would be done, and that will be given back to the application layer. To answer your query, whether we write on application layer or database layer, CDS view are written on the application layer, which do the computation in the database layer.
So that means from CDS view, like for if any company using multiple databases, so it can extract the data from CDS view. Like for example, HANA DB, Oracle DB, or maybe Microsoft DB, different systems if it's using. Because what you are explaining to me, like CDS view can extract different database as well, and then that all the data from different sources get into that HANA DB, and all the calculations done by HANA DB, and then give the result. Maybe that's what
Let me take a screenshot of this, and then I would be explaining a little bigger picture. That's not a correct statement. So in that architecture, we'll be doing little differently. So we are having here, this is my HANA DB. CDS view is a functionality which is very much linked to your HANA database. So if the another database is there, it can be XYZ database. What we need to do is that we need to bring a data here. You can bring a data into the different schemas if you want. Okay, so your S4HANA data is there. And then this X database data also you have brought it here. And then you are having your S4HANA application layer. Here you can write a CDS view which can take a data from both and combine it. Okay, there are the chances if the other database is also HANA database, one single CDS view, there is some technologies are there, it would be able to do it, but generally it is done like this. If the data is there into the single database, it will do the calculation and bring the database to the application, bring the data to application layer.
Okay, so okay, got it. Yeah.
For suit on HANA.
So from the XDB to bring the data to the S4HANA DB through some integrations, how is it brought?
Yeah, there are the multiple integrations available which you can bring it with SLT, and then there is another integration, a lot of integrations also available by which you can bring the data to the HANA database.
For suit on HANA, the CDS views, is it on the database layer or on the, it should be on the database layer, right? Not on the application.
Suit on HANA, yes, it is on the database, but it is in Suit on HANA. What happens? We don't call it CDS view. It's another view.
Oh, okay.
It's a simple like a views. So your HANA database also has some views. So let's say these are the tables in HANA database. Then we are having another kind of views in HANA database, which is analytical views plus calculation view. So these views you create on HANA DB itself. So these views can combine these multiple tables. These views has been used by, earlier we discussed about HANA Live. So HANA Live use these views. Multiple views you can create, and then that can be fetched to any application. All SAP BI applications now support these views, and then you can generate analytics out of it. That kind of dashboards can be generated. So these are the different views. Calculation
So
view,
CDS view and this
analytics.
view is different, huh?
These views are different, right? This has a this views can be created with the program. Plus, we also have a graphical tool where basically you can just bring in the table, connect the tables with each other, and at the back end, your SQL code would be automatically written. Okay, so this can be done with the graphical tool. CDS view is, as of now, I heard earlier that SAP is working on to create a CDS view through the graphical tools also, but I have not seen any development so far. For now, CDS views are written ABAP on HANA, which is similar as your SQL coding, which you need to do through HANA Studio by logging into your application layer. So HANA Studio, you can log into application layer also, and you can also log into database also. So in tomorrow's session, I will take you to the system and we will see this concept of CDS views, that how the CDS view looks, how we can see the proxy, how we see the data into the HANA Studio in the MARD table and SC16 MARD table, what would be the difference. So that all in the system we'll be seeing tomorrow. We'll also speak a little bit on MATDoc and MATDoc extract table. People have a very limited knowledge on that why these two tables are there, why two tables are required, how MATDoc would be different from the MATDoc extract table. So that also we'll be talking about in tomorrow's session. Okay, by the time I'm giving you homework to everyone to you, okay, you need to identify what is the difference between MATDoc and MATDoc extract table. Try to do some search and try to come up with the answers. So what is the difference between MATDoc and MATDoc extract table? Now the forum is open for any kind of questions you are having. You can ask it now.
Yeah, Parminder, I just had one simple question. Like, what is CDS stand for? Like,
Core Data Services. CDS stand for Core Data Services.
Will Parminder, will this CDS views calls the proxy objects like a functional consultant? How would I say an ABAP, like what he needs to use, or will he have knowledge of what he needs to do?
ABAPer are supposed to have a knowledge of what they need to do, but I will show you tomorrow that you can actually in your functional specification, if you're using a table, you can also write a CDS view which that table is associated with it. That we'll see tomorrow.
Okay.
Hi, Pamela Samrat here. Normally in HANA, I have what observed that your older tables like MSEC, MKPF, all these tables have included their new tables like MATDoc extract. So many times I get confused that whether I will be using your older table to extract the information or I will use tables which are available in S4HANA.
So sorry, can you please go on mute? Yeah. Sorry, a lot of background noise is coming. I'm not sure. Okay, now it's good. So the best practice from SAP is to, whenever you are writing a technical program, you should directly use a CDS view to get the data. Okay, that is the best practice. Although if you would be using a MARD table in your logics, actually MARD table will automatically go to the proxy, and that proxy would be automatically calling the CDS view. So even though you are using a table, actually at the back end of that table, you are automatically linked with the CDS view, and CDS view is giving the data. But best practice is to directly use the CDS view in your programs.
Another question, how do you know that the CDS is available or not?
That I will show you tomorrow.
Okay.
Guys, before we close the session for today, I want to give you an information. You all might have received an email from support@sastrageek.com. So we want you to, all of you, to save one WhatsApp number and reply to that WhatsApp number saying add me. So we will be having an announcement, whatever announcement we will be doing. We are having a broadcasting group in WhatsApp, where basically we are not adding you to any group. Only thing that we put the broadcasting information, like quick reminders to you about the session, meeting links about the session, and we'll be letting you know that once the videos has been available on the site, so that you can look and review it. If any new document has been added or anything which we want to broadcast information, we'll be doing it through. So let me quickly open that email which Arsh has put it, and I will guide you to do some steps so that you all are not missing any information or any update from ours. So this is the email which you might have got from Arsh. Okay, so this is the number mentioned here. This is the Sastrageek support number. Anytime in future also, if you are facing a difficulty to join the session or anything you want, you can directly message on this number. Okay, it works only on WhatsApp. Direct calling is not available on this number as of now. And you need to save this number as a Sastrageek support, or with my name or any name. You need to store this number in your mobile phone and drop a message to this number, add me. And then we will be putting in a broadcast group where basically any information, any updates we'll be sharing, you will be receiving a message on your WhatsApp. Okay, so this is basically for the notifications. If once we upload the previous session video on the site, you will be getting a notification message from this. So please do that thing so that you are updated with all the notifications. Okay, anyone has any questions before we close the session for today? Okay, guys, thank you for joining this session. We'll be connecting back tomorrow, same time. Thank you for joining.